How's it going, everyone? This is Matthew Landis, one of the Hive staff members, and I'm here to teach y'all how to use the basics of FabCreator. This is what turns your standard vector files into something the FabLite can actually use. So in this tutorial, it's just going to cover basic things of how to use this tool specifically for turning your vector file, your 2D vector file, into a 2D cut. So again, all just for the sheet metal. If you want to use tubing, that'll come later in a different tutorial. So to start, go up to File and import your design. I'm going to go and open up this little Hive model I made. So as you can see, this is what it looks like. If you're importing a .dxf, you'll sometimes see a pop-up which will ask you what is the units being used, as well as where do you want to place it. Most importantly, just get those units right, because whatever you exported from is whatever you want to import as. And if you have any issues where something seems dramatically smaller or larger than you expect, that's one of the most common causes. So as you can see right here, there's a little display viewing window where you can go and scroll in and out. You can see this is our whole bed that you see on the inside of the FabLite. If you hold the scroll key down, you can then go and pan, and if you hold shift and right click, you can see different angles. For these are just two-dimensional cuts, but when we get to cutting tubes, it'll be more relevant. So next thing I'll show you is these different categories. There's these four. So cut is exactly what you expect. It's your standard, just cutting straight through the metal. Then there's engrave, which is actually drawing the lines. So it's just tracing out these shapes, whatever you define it as. And then rasterizing is actually shading it in the whole way. This fourth category of reference doesn't actually do anything. All it is again, just reference. So you can see it when you're designing your model, but the laser itself doesn't do anything with it. So by default, all of your lines, so these are all just polylines, so little basically vectors, show up in the cut category. We can go and select between them by either just clicking on them here and you see it gets highlighted, or doing the opposite. You can go and just arrow up and down to go through them. I'm personally going to use this little select tool up here, where I'm going to select the word the, and it highlights all of this. I'm then going to right click on it and say make it in rasterizing again, so like shade it in. And then if you go and see this, here are the new pieces. And it also changed the color to blue on the screen. You can again do that anywhere for any of these cuts. I'll go and make the rest of them all to be engravings, so just traced. And then, so this means we're only going to be cutting out this outside shape. So then we're going to continue on to the next tab, so edit. This is how you're going to be moving around your piece. So if it imported and wasn't exactly at the origin, or if you just want to move it around, so you add some extra buffer room along the side, you can go and move that. So just click move, rotate part. So you can go and specify where you want to move it. You can also just move it to the origin. That's the easiest thing to do. You can also rotate it here. Rotation isn't possible on the actual like FabLite itself, but these positioning you don't need to worry too much about. If you're using just like a big sheet metal, you can go and specify exactly where you want it, but also if you're working on a piece of metal that already has some cuts in it, you can go and wait until you're on the machine itself and move your design around a little bit more. Still over there. Okay. Then also here, another quick thing is you can add some text if you want to just add that. Cool, now we're on the properties. So first thing you see is this database. This database is all of the speeds and power settings and a few other tweaks that are all provided by the FabLite team. So by default, we're always going to pick this FL4500. That's just the actual laser that we purchased. There's also the 1500 and 3000, which are the other models that they sell. So you can go and specify what units. This is just going to be what is provided to the FabLite machine. And again, for this, we're just going to stick with sheet. From there, you go and decide what material do you actually want to be cutting on. So that's whatever is in the machine. This cuts pretty much anything conductive, but the basic ones that we're going to stick with is just aluminum, stainless steel, copper, standard steel, and anodized aluminum. So I'm going to pick just standard steel. You can then go down to thickness, define whatever is the thickness. This is most important when you're doing cuts. If you're doing something without cuts, this is less important, but especially if you're doing a cut, you want to make sure this is what's expected. You can see it cuts, again, they say for prototyping volumes up to this 1/4 inch. But some materials, if you look at, for example, aluminum, only goes up to a little bit past 1/8 of an inch. So this is going to be our little sheet size right here. So you can see that's this white line tracing the outside. And engraving, pretty much always leave the same. And rasterizing, this is your, let's say, the resolution of the actual shading in that you're going to see. So if you have any issues where the lines are visible or there's like spaces between the lines that the laser is actually cutting across, you can change this. Be very careful and generally go and refer back to MPI or staff before changing anything. So now we're going to click accept. Cool. Now you see these little tabs pop up. This is because in the tabs category, we have by default to automatically generate 4 tabs. These tabs are little spaces in the cut. So you can see the length is in this case like 0.15 millimeters. So extraordinarily small, but this keeps it so that the piece doesn't fall through. The laser is smart enough to do the actual cuts last. So it's not like it's going to cut out a piece, it fall through, and then go and try and engrave nothing. However, it's generally still good practice to have tabs if you're cutting something out, even if they are somewhat small. So if I want, I can go and insert additional tabs. So I just go click here, wherever I want. You can move them very simply just by dragging them around, and then you can also just delete them. A good rule of thumb is at least 2, especially for something like this. 2 makes it nice and easy to wiggle out, but if you want to be very certain it's not going to move, 3 and honestly at most 4 is pretty perfect. So then we're going to go to the final tab of job. This is where you're going to see your job info, a little, basically a summary of what you're expecting. So it gives you job time, as well as you make sure that the material, not only what it is, but the thickness is right. It's really easy to accidentally just like not set the proper thickness, and that'll cause issues with your cut. One other thing to highlight is if you have a design where you want to make, let's say 4 or 5 of them, you can go to step and repeat. Here you can specify your actual sheet size. So let's say I have a 1000 millimeter by whatever 300 millimeter piece of metal inside the machine. And I can then even go and just do an autofill. So basically just fill the sheet, pack it as best as possible with all of my design. So you can see, again, the grid is the whole bed. And if I have a piece of metal that's about this size, these little dashed pieces are where we're going to have, in this case, say like all of these different cutouts. So not only is it going to cut here, it's going to do the exact same design in each of these. You can then click apply, and there you go. So we're going to get our 20 pieces. Each of them, it estimates, are going to take a little under 5 minutes. I found that this estimate isn't perfect, but it's, again, a solid estimate. And then when you're done, just click make and save. It will save it as a .fab, and then you can just make sure you save that to the flash drive. Finally, you're just going to take that flash drive out of the computer, plug it into the Fab Light, and you should be good to go. Okay, so hope this helped give you at least a solid introduction to FabCreator. And if you have any issues, please don't hesitate to reach out to myself, any other staff members, or any other PIs at the Hive. Good luck.